so today we'd like you to write down some information about sequences. We're going to do two kinds of sequences, arithmetic and geometric. The difference will be pretty obvious as we go through this. So take your notes out and fill these out as you go. We'll handle the rest in class tomorrow. A sequence is a function whose domain is a set of consecutive integers. A finite sequence has a limited number of terms. You're going to hear the word terms a lot with this this material. The other thing you can say about a finite sequence is that it ends. An infinite sequence obviously goes on forever without stopping. So there's going to be one major difference between the two of them is one ends and one doesn't. The domain is the position of each term. Domain is still kind of like your x, it's your independent variable. And the range is still kind of like your y. They're going to have a little bit of a different, I don't know, idea behind them with this material. The range is the term itself, so the actual term. And we'll be able to draw some pretty solid examples of that as we go through this. So don't worry too much about these terms yet. Kind of revisit them and write your own definition as we go through each slide. Okay, so an arithmetic sequence is defined as a sequence whose terms go up or down by a constant difference. So this is your garden variety, like adding 3 each time, or adding 10 each time, or subtracting 7 each time. So up or down by a constant difference is how we're going to determine something's arithmetic or not. So this guy here, from 5 to 11 plus 6, 11 to 17 plus 6, pretty clearly we're going up by 6 each time. So this would be classified as an arithmetic sequence. And the common difference is plus 6, and that's going to be represented with the letter D. In this one, we're adding 4, and then we jump and we add 2 a couple times, so that's no, and therefore it doesn't have a common difference. The main thing we're going to do is write rules for these things. The nth term of an arithmetic sequence with the first term A1 and common difference D is this here. We're going to ask you to memorize a couple formulas. This is the first formula of the bunch that we would like you to memorize. So keep a note of this, put a star next to it, whatever it is that you need to do to draw attention to it for yourself. Writing rules is relatively straightforward. Writing a rule for the nth term of an arithmetic sequence with those numbers, and then find the 20th term. Anytime you're presented with one of these questions, we encourage you to start with a sub n equals a1 plus n minus 1 times d. For what it's worth, the location of that d doesn't matter. You can also put it in the front of that if you'd like to. This is just the formal notation. So to write a rule, an, we need to know the first term. The first term is whatever they provide you with in the problem. So that's a1, 50, plus n is your variable, so you're not going to know it. And the minus 1 is part of the formula, so it's got to be included. D is what you need to find, which pretty clearly in this problem we're going down by 6 each time, so that's going to be times -6. To write the rule, the only thing that you need to do is distribute this -6 in here and simplify. So 50 minus 6n plus 6. So the rule for the sequence is 56 minus 6n. To find the 20th term, probably not shockingly, you're just going to substitute 20 in for n. 56 minus 6 times 20. So the 20th term is going to be equal to, is that -64, I think? I can check my math, but I think that's right. So revisiting our topic above of domain and range, this 20 is a member of the domain. It's kind of like the X value that you plugged in. This negative 64 is a member of the range. So those aren't just the domain and range themselves. They're parts of the domain and range. And that's what we're talking about when we say the term number and the actual term itself in terms of domain and range. A little bit more involved of an example would be one like this. Arithmetic sequence where one term, A8, is equal to 50 and the common difference is 25. Again, all you have to do to be successful with these is start with the formula. Notice how I put the D in front first this time. You're not given the first term this time, but you are given D. And this time you're giving something unique with A8 being 50. That means the 8th term is 50. So we can put 50 in for the term number, or for the term itself, excuse me. A1 plus 0.25 times, and then since the 8th term is 50 and we replace the term with 50, we need to replace n with 8. So we end up having this equation. 0.25 times 8 is, I think, or times 7, excuse me, is 1.75. So A1 ends up equaling 48.25 by doing a little basic equation solving. And then you plug that back in to your original formula. AN equals 48.25 plus 0.25 times n minus 1. And then finally, after some simplifying, I believe you end up with 48 plus 0.25n is your rule. So this all starts with the formula. I can't emphasize enough that anytime you're doing one of these questions, you start with this formula, fill in what you know, and then do a little bit of basic algebra to back solve those things. The other kind of sequence we'll be dealing with is called a geometric sequence, a little bit different than arithmetic, but the ideas are somewhat similar. The ratio of any term to the previous term is a constant. The constant ratio is called the common ratio. And this time, instead of a D for that, we're going to use the letter R. So what you're looking at is multiplying or dividing by the same number each time. So in this case here, we times 2, but then we times by 3, and then we multiply by 4. That's clearly not the same number each time. We're not even adding the same thing either time, so this is neither. That's a kind of sequence, but not one that we're going to deal with. We'll skip down to this one, which is a little easier, plus 6, so this is pretty clearly arithmetic. And D equals 6. Here, we're dividing by 3, and that pattern continues throughout. Again, so when you're dividing by a number consistently, it's geometric. The R is not going to be dividing by 3, but dividing by 3 is the same thing as multiplying by 1/3. So the R in this is 1/3. So whenever you're doing division, you want to think in terms of a fraction rather than that division. Here's the rule. A1 is still the first term, R is the ratio. If you notice, this is an exponential function. Arithmetic's linear. These guys are going to be exponential. So it's, again, a very similar process. Everything's going to come back to the formula, and that's the second formula that we want you to memorize for these particular types of problems. So write a rule for the sequence, then find A8. What you need to do is first figure out what's the ratio, meaning what's it going up by each time. If that's at all a struggle for you to just visually see this, which I would understand, you can simply do -12 divided by -8 and -18 divided by -12 and just kind of see the ratio of the terms going forward. So the The second term divided by the first term will give you something, third by second, fourth by third. So you can kind of wiggle your way around it, I guess. And I think in each case, these fractions reduce to 3/2 or 1.5. So we're multiplying by 3/2 or 1.5 each time. So R is equal to 3/2. A1 is equal to -8. So we go to our rule, a sub n equals a1 times r to the n minus 1. Just fill in the blanks. -8 times, and that's always a good idea to put your factor in parentheses, and that would be the rule. We'll bypass the need to find a8. You would just plug in 8 to find a8, and that's going to become old habit for you before long. Final example, a3 equals 5 and r equals 2. It's going to be basically the same thing as the arithmetic question, except with a different formula. You know the third term is 5, so we substitute 5 there. We don't know the first term. We know the ratio is 2, and we know that n is 3 because of that term. Do a little bit of quick math. A1 times 4, so A1 equals 5/4. And finally, we can write down our rule. So that's a quick look at arithmetic and geometric sequences. Tomorrow we'll start class off with a question and answer session on these. So please, on these notes, if anything was very confusing to you, write down some questions so you can come into class tomorrow and ask some intelligent questions to generate some good discussion.